So welcome to you, good morning or good afternoon, depending where you are. And thanks for attending this BIAflows tutorial on reproducible deployment of bioimage analysis workflows and their benchmarking. So I'm Sébastien Tosi. I work at the Advanced Digital Microscopy Facility of IRB Barcelona. I'm an electrical engineer turned bioimage analyst about maybe 10 years ago now. And basically I've been guiding the strategical development of BIAflows for the last 4 years. I'm here today with some of the developers, actually almost all of them. So we have Raphaël Marée from Institut Montefiore. He is the lead developer of Cytomine, an open source project upon which BIAflows is based. Then we have Romain Mormont, so he's a PhD researcher in Raphaël Labs. Then we have Volker Baecker from MRI Biocampus Montpellier. Volker is a seasoned programmer and also doing bioimage analysis where he is. And finally, Benjamin Pavie from VIB Bioimaging Core in Belgium, also doing bioimage analysis. Okay, so the outline of the tutorial is this one. I will start with some background on the project, what were our aims, why we developed this tool, and what can it be useful for. And then we will have a short round table. Maybe you can all introduce yourself and also motivate why you got interested in our project or what you would like to use it for. So let's keep it short, maybe 2 minutes each. Well, depending on how many we are at that point, it can be a bit longer, but let's keep it short. Then we will have some technical introduction on the challenges when doing reproducible bioimage analysis, or image analysis actually as a whole, and benchmarking, and also the technological solutions we've been choosing while building the platform to address these challenges. No? And then Raphaël will perform a demo of BIAflows. So as you will see, it's a web platform. You don't need to install anything, so you can also try it for yourself if you haven't done it before. And then we will have the hands-on. So this is the longest section of the tutorial, where you will actually have to do things yourself and add your own workflow to one of the BIAflows instance, what we call the sandbox server that is open for this, and then benchmark your own workflow on the platform, etc. So, and then finally we will have a wrap up with maybe some more questions or generic discussion. But again, I insist, please interrupt me or ask any question if something is unclear. For the hands-on especially, I think it's quite convenient that you have the slides from my presentation on your machine, because then you can copy-paste some links or comments that we're going to use. So here on the first slide, you see on the upper left, you have a short link. So please copy this link, open it. It's a Google Drive folder where you will see the presentation I'm showing now in PowerPoint and PDF. Okay, so you can access the slides and use them. Okay, so let's start with the generic introduction. BIAflows has been developed within a network that is called NewBIAS, the Network of European Bioimage Analysts. So it's a Cost Action. It's funded by some European money from Cost Action. It started in 2016. So yeah, it's now ended, at least in terms of funding, and we are looking for new fundings, new grants, or ways to push this ahead. But basically, the general intention of this network, so this is prior to 2016, we started discussing about this in 2012 or 2013, more or less. We realized that the position of bioimage analyst was not really recognized as such. And most people, at least in the imaging platform, they were doing bioimage analysis as a side work, let's say. So they were either microscopists, biologists, or, and they were doing it in their own way. But let's say the knowledge was not very well organized. And also the position of the bioimage analyst was not really well understood or recognized. No? So our intention was to promote a number of actions so that it improves, including training schools, conferences, releasing textbooks, material for this kind of materials, and also defining a curriculum. No? And finally, also scientific missions to promote exchange of knowledge. Two important actions in this network, and this is more the topic of today, are two web tools that were developed, so you can see on this slide. The first one is called BEU. This is the URL, you can find it. And it's basically a repository of tools that you can use for bioimage analysis. So software, workflows, any kind of tools that can be useful should be listed there. You can also edit it if something is missing. It's quite open. And importantly, for the search engine, it's based on several taxonomies. Some taxonomies are more oriented for biologists, others for developers or algorithm developers. So we try to be inclusive, so that it's quite easy to find these tools. And the other web tool is BIAflows. So the web tool we are more interested in today, and it's about benchmarking workflows, automated workflows. So going from images to results. The results in that case are object detection or object-based, so like segmenting objects, tracking them, detecting them. So this kind of automatic workflows. And we are aiming at reproducible deployment, so that once the workflow is packaged and included in the system, anybody can use it and will obtain exactly the same results as the results that were obtained when you packaged it. No? So we have two web servers. You can see the URL at the bottom of the slide. The first one on the left is the main instance. It's a curated server, and it's read-only for most people. So that's where it's a sort of vitrine of the workflows and the results and the images we use also to benchmark the workflows. And then we have a sandbox server that you can see on the right. That is the server we're going to use today. So this server is completely open. You can upload images, your own images. You can integrate your own workflows and try the whole framework this way. Okay. So this is the server we're going to use today. So why have we decided to do this? I already motivated it in a sort of generic context initially, but in terms of benchmarking and reproducible deployment, the landscape, at least, yes, prior to 2016, so we are talking about 2012, as I mentioned, was that there was no real culture of publishing new bioimage analysis workflows by comparing results on common reference datasets and with the same metrics, so the same way to compare them. So this was the first issue we could identify. No? Then the end users, for instance, biologists, they were mainly dependent on the major bioimage analysis platforms, such as ImageJ, integrated new state-of-the-art workflows. No? So there was a lag and a need for, let's say, integration of these workflows before the big pool of end users could really use them. So this is another issue we thought. And also the workflows, most of the time, they were published as side results in biology papers, for instance, in the methods section, not always really well documented, and test images were often missing. So it was difficult to first, prior to using a workflow for our own images, test it on images for which it was guaranteed to work. No? So all of this was missing. Comparing to other fields such as computer vision, for instance, the way people were working is completely different in this field. So published workflows are almost always benchmarked on popular reference datasets. It's actually a strong requirement to publish at least in the big journals. No? The papers were completely dedicated to the workflows and also their comparisons to other methods. So it was like the bulk of the paper. So this was something good and something we wanted not to import to our field. Then less good, developers were often benchmarking their workflows independently. So they sometimes had to re-implement methods. They were comparing their own methods too, and also tools to benchmark the workflows. So it's something we thought we could improve. And then finally, the workflows were not very user-friendly to use or reuse without expertise. No, sometimes you had to compile code or have some specific operating system to run them. Also, the documentation was not always super detailed, mostly because people were racing for the next paper. No? So once something was out, they were already thinking in the next one and not so much in making their tools usable and used by many people. No? In a different field, so closer to bioimage analysis, medical image analysis, the field is organized a bit differently. Benchmarking is quite strong in this field as well, but it's mostly articulated around challenges, so competitions, where people can submit the results of their workflows and then they are compared this way. There are also some annotated dataset repository, so I'm showing here one, but mainly it's challenges. No? And there is a page, a central repository where you can find most of the challenges. It's called Grand Challenge. So today there is 237 challenges as of today. So that's quite many. But unfortunately, if you start to look at the challenges and the image datasets that were used for these challenges, if you type keywords such as histology, pathology, cytology, microscopy, so like biological images, only 15, so in total 24 datasets corresponds to bioimage analysis. No? So it's only a fraction of the whole challenges. Most of them are based on medical images techniques such as MRI, CT, etc. Finally, I'm sure you heard about Kaggle. So Kaggle is way broader. It's any kind of challenges in there. There are many datasets, 62,000 more. But again, only very few are related to microscopy images. About 17 I could count by filtering with keywords again. Okay, so challenges. It's already a good thing, something we would like also to promote in bioimage analysis more, but they have limitations. First of all, as I said before, only a few microscopy datasets are available or used for these challenges. So it's something we could promote, but it's not the case as of today. It's only one problem per challenge, okay? And worse, for every challenge, since they are organized in a sort of independent way, even if the challenge is on the same type of images and problem, the format of the annotation, for instance, of the biological objects in the image, is not always the same. No? So everybody has his own way or own standard. Also, for the same problem, again, the workflows are not always evaluated in the same way. So different metrics might be used. So it makes it difficult to compare or group. Also, the workflows are often distributed as compiled code that you can execute, for instance, on a specific operating system. So it's not super reusable in a generic way. The benchmarking is not automated most of the time. So what you submit are the results of your workflows, but they are not automatically evaluated by the system in a reproducible way. And finally, the challenges are discrete events, discrete competitions, often organized during big conferences. So they are not really like, it's not like a continuous benchmarking that would be fully public and updated each time a new workflow is submitted, no, so to say. It's not fully true because some challenges have different editions, but still there are discrete events, no? So that's why we decided to develop BIAflows as a, let's say, a third generation of way to benchmark that would be more transparent, public, and automated, and based on a web platform. No? So we defined the standard interface for different problem classes, such as object segmentation, object tracking, filament tracing, etc. So you will see we have already many problems in BIAflows, problem classes. And then a mechanism to pack the workflows with their entire environment, execution environment, to ensure reproducibility. No? So the workflows can be tested online on a set of annotated data sets that recapitulates, as of today, 15 common bioimage analysis problems. The results can be visualized together of different workflows, even if the workflows are coming from completely different platforms. So as you will see, we have many platforms, ImageJ, IC, Cell Profiler, Python, or also compiled code. So it can really be almost anything in there. And then the benchmark metrics are automatically computed on the results. Okay, so the workflows run online on the server, and the benchmark metrics are computed and can be explored in an interactive way. So in every problem, you have many images. You can get the statistics of a specific metric over all the images, or also see it per image. No? So Raphaël will demo this, so I stop here. This is coming actually not now, but after the technical presentation by Volker and Romain. But before this, I will take your questions if you have some, and then we will go through this roundtable I mentioned initially. So please tell your name, where you work, what you're doing, and then why you got interested in our project and what you think it could be useful for you. Okay. So to make this a bit more organized, I think I had the participant list here. We can go by alphabetical order, starting with Jean Brochet, or Yann, sorry. So yeah, I will mute.
Yeah, hi. Yeah, so my name is Jan, and I am since 2012. So I'm trained as a biologist, and was by PhD thesis, postdoc, and so on, getting to image analysis, and then basically started in 2012 Biovoxel as an independent or freelance bioimage analyst, and giving mainly courses for PhD students on basic bioimage analysis, where those kind of workflows basically are interesting. And so exactly what you've mentioned already beforehand, like people develop that, I tell them, publish that, make your macros, publish them, but then it's exactly the problem. So not tested, and it's published somewhere, but potentially not directly in the paper or on any kind of homepage, which nobody finds. And so that is actually where I think it has a big potential for the few things I was reading about BioFlow to also mention that to all students. I basically encountered to say, like, okay, there's a platform, you can go there and make sure that people find your workflows and also independently test it. So that was my main goal, actually, to get to know the platform a little bit better. And also to, I mean, since I create quite often several workflows, partially also from the user list or so, and I had comments already, like, for some, couldn't you make it like public somewhere where people can just download it? And besides the user list, BioFlow would be perfect for that.
Okay, thanks a lot. The next participant is Konrad Okichi. Sorry if I said it wrong.
Yeah, hi. So I'm an engineer at Genelia, and we've been analyzing a lot of imagery over many years. We came across all these problems early on, probably 10 years ago, and also didn't find any solutions at the time. You know, over time we've developed some in-house stuff, but it's mostly at the level of being able to take an image analysis pipeline and apply it to, you know, imagery at a large scale. So scaling things in a cluster and doing consistent pipeline runs for many thousands of images. You know, our tools are kind of internal. They're specific to Genelia, and we're looking for something that's open source, open access, and you know, sort of community supported. So that would be yeah, what we're looking for.
Okay, thanks. Next participant is Linda. Chance.
Hello, I'm Linda. I'm imaging specialist in the lab, which is located within the molecular pathology department in the Netherlands. The Netherlands Cancer Institute. And I'm an imaging specialist, so really hardware, software. I'm pretty much doing both. And we use a lot of software, like commercial software. But the thing is, what I find is, it doesn't really do what we wanted to do. And also we generate a lot of data. Our data is like, we have like 100 terabytes per year. So when I saw the benchmarking, I found it's really interesting because, we can't really afford to halfway, we need to change our methods. So we need to do this in advance. We need to find a workflow that works. And then, to really process our image. So this is why I think this could be useful to us. And and the other things, I'm really a big beginner in image processing. So yeah, I'm here to learn.
Okay, next Marion Louveau.
So hi everybody, I'm Marion Louveau. So I'm bioimage analyst. I'm also R developer and data analyst, and I'm working at the Institut Pasteur as application specialist for the software IC. Mainly I do image and data analysis for biologists. I also do user support on the IC software, and mainly I collect feedbacks and feature requests or bug reports to report to the IC software developers. I also give trainings on IC, and I'm also a community manager for IC. So I do the communication around IC, especially on Twitter. I'm interested in BIAflows for myself first as a bioimage analyst, and also for IC to better document the possibilities for the users and encourage them to have good practices when they are doing bioimage analysis.
Great, thanks. Next participant is Tong Li.
Yeah. Hello, everyone. My name is Tong Li. I'm a postdoc at the Wellcome Sanger Institute at Cambridge. At Sanger, actually, we have a lot of image data coming from different groups. Our problem is just that the user doesn't know how difficult the data is. So it will be great if we have a BIAflows, some kind of tool that can give metrics of the difficulty of the images, so that as an analyst, I can make better decisions instead of spending days of explaining to people how difficult this image is and which method to use. And more generally, I knew this BIAflows several years ago, and I just didn't have time to look into that. So this is a good occasion just to dig deeper to understand how BIAflows works and all the metrics that you use and what kind of benchmarking tools that you are using. everything actually. Thank you.
Okay, great, thanks. Okay, and then we have Daniel Sage. So Daniel, you were not connected when we started. So yeah, just tell your name, where you work, and how you got interested in BIAflows, and what are your expectations.
Yeah. Everyone, so sorry for the delay. I was lost with the Zoom link. Okay, so I'm working in the EPFL in Lausanne, Switzerland, and okay, I'm mainly research engineer, developing bioimage analysis workflow, many plugins for image and so on. And okay, I'm interested by BIAflows, specifically with the features of the benchmarking, the tools that you build around the benchmarking. Yeah. Thank you.
Okay, thanks. So I think everybody have spoken. If I missed somebody, please just speak. If not, we will move on to the next section of the tutorial with the technical presentation on challenges on reproducible deployments of bioimage analysis workflows and benchmarking. So Volker, can you share your slides, please?
It's actually Romain who will present.
Romain starts. Okay, you changed that. Okay.
Can you see my screen?
Daniel, can you? No, it's okay. Thank you.
Okay, here it is. Okay, so for this segment of the tutorial, we'll look more into what we mean by reproducible image analysis, why we care, why is it hard to achieve, and how we answer to that with BIAflows. So first, a definition of what reproducibility means. It's more a formal definition here. So when we talk about reproducibility, we refer to the ability of a researcher to duplicate the results of a study with same materials and procedures. So, this is a definition, and here this term can be confused sometimes with other terms that touch the same subject but are quite different. So we differentiate reproducing results from replicating results. Like replicating is more different people doing the same experiments with the same setup and trying to achieve the same results. Here, the reproducibility means more varying the experiment or the setup from a different person. We are also interested in the reuse part. So when a workflow has been replicated, when the results have been replicated, reproduced, we might want to reuse the workflow in another context to solve a different problem. So reproducibility, it's actually hard. When we look at workflows and software, it can be overlooked that actually software is not something that is fixed, because software evolves with time. You have updates, you have bug fixes, you have new features, and software usually interacts between each other. So when you change one, you might break something in the other. So over time, you have this kind of state of a software that evolves and make it difficult to reproduce a result when you maybe come back a few months later on a workflow, because maybe this plugin has changed something. And so that's something that is actually difficult by the very nature of how software evolves. It's because of what we call software rot. Why do we care about reproducibility? First, let's look at what could be a timeline for a bioimage analysis project. So you have some hypothesis you want to test about some biological objects. How you will try to test this hypothesis is by testing using imaging. So to do that, you will experiment, you will prepare the objects, you will acquire the images with microscopes, scanners, and then you will apply some bioimage analysis. So you will extract some data about the objects, and then you can analyze this data to extract relevant information for testing your hypothesis. Then you can conclude about this. It's a typical, I would say, a research workflow for bioimage analysis. And so the question is, why should it be reproducible? But first, because in a broad sense, science should be reproducible. That's how science works. We want to actually find and to define if something works. We have to first have experiments that prove it works, and to be sure that those experiments are relevant and made correctly. We need people to try to make them again in a different context. So that's why we care, and it's reproducing experiments. It makes it possible to find errors, or and also avoid wasting time if you build on top of those errors. And as I said, if something is reproducible, it means that it's potentially reusable, which is very interesting for bioimage analysis communities, because finding a tool that works for you, obviously you don't have to redo a tool and create a new tool yourself. So you gain very much time. So who are the targets here? People want to reproduce and reuse workflows. We have obviously reviewers of publication. You cannot usually just read a paper to see if something works. It takes some time, but the best way is probably to reproduce the experiments and try to replicate the results. Also, the bioimage analysts and biologists that want to use them those workflows on their own images. Also, developers that build tools, and yourself or other people who want to reuse again your workflow. They want obviously to be able to obtain relevant results from them. So what can go wrong when you try to reuse a tool? Why actually reproducibility is hard? Well, if we start really from the ground, I would say that the first thing that would prevent reproducibility is the fact that the algorithm is not actually defined or explained or provided in when a research is published. I think it's something that is evolving, and now more and more papers are providing more details about the algorithm, but it was possible to find in papers sentences like, we use that platform, we use ImageJ for image analysis. So with such description, you really cannot do anything from it. You don't have any information to replicate, reproduce, or reuse. When the algorithm is detailed in the paper, sometimes the software is not available. When I say software, it can be either an executable software or even parts of the software. Maybe you need the specific plugin, you need the specific file to execute the plugin, which is not provided or is hard to find. And even when you have all those parts of the software or software itself, sometimes you don't have enough documentation to run it. So how do you install the software? What parameters should you use for your problem? How can you run the software? But that's not all. So even if you have all of that, and you want to, for instance, replicate here a result, you might not have access to the original data. Also, the parameters might be missing. So you would have to test on your data, but okay, if it doesn't work, does it mean it's broken, or it's just because the data doesn't fit the hypothesis of the initial hypothesis that were used to make this workflow? And let's go a step further. If everything is available, okay, you have this macro that has been shown to work in a paper, and you try to run it on your laptop, and it doesn't work because it says that you have an environment issue. Maybe you are using the wrong version of something, or you are not on the same operating system. You have conflicting libraries. So here we are talking environment issues. And finally, maybe you have you are using a workflow that used features that were deprecated and are outdated and not available anymore on your platform. So there are really many things that can go wrong with softwares, and here are some of them. So how can we actually solve this problem? It seems quite daunting, but the solution is to actually make everything available. Everything is the workflow itself, all the dependencies, scripts, macros, plugins. The environment should be provided in some ways. So the environment is the operating system, the libraries, the platform, plugins, and very important, you have to provide versions of your dependencies and everything in the environment. Because if you don't provide a version, again, with time, this environment might change and might break your workflow. You need obviously to document your workflow, how it works and why it works in this way, what are the hypotheses. And also, you should provide data and parameters used in the initial analysis for people to be able to reproduce or replicate your results. Obviously, make everything available. It should be available somewhere, so maybe on the web or any public places where you could find it. And because again, the web is something also moving with time, maybe you want to keep and archive a local copy of your workflow. So yeah, I said it sounds pretty demanding, but it's actually possible. So first, this everything that you have to provide, when is it available? Well, when you define the workflow, when you make it the first time, you have access to everything. So it should be the time where you do this effort of making it available and reproducible. And then you can obviously document after you have packaged everything. And today we have actually a wide range of tools that we can use to achieve that. So here are a list of tools that you can use. So to share your code and workflows and files, you can use, for instance, Git and GitHub. You can use, to share your environment, you can use Docker and Singularity, which are systems that can provide something containers. So it's like a virtual machine, but like more lightweight that actually defines an environment where you can run software. For documentation and code, you can also use Jupyter notebooks, for instance. It's a way of providing, for instance, Python code with documentation, and you can run interactively the code. And also to share the data, you need a public image repository. So you have a lot of options for that. Obviously, you can use IDR, Omiros, Cytoman as an image database, Zenodo, or why not BIAflows, which also provide this feature. So Git and GitHub, for those of you who might not be familiar with that. So Git, it's actually a software, a system that is a distributed source code management and version control system. So you can track changes in a code base, labeled changes, and it makes it very easy to keep track of what is moving in the code and to document actually the changes of a software. And then coming with Git, well, Git is an independent software, and then you have GitHub, which is a public host for Git repositories. So it's now kind of a standard to share and to provide open source software projects. They have a lot of very useful features that you can use related to Git to provide your code and also document it and interact with your community. Then you have, as I said, you have Docker and DockerHub. So Docker, it provides a way to deliver software in containers. So a container, as I said, is like a virtual machine. You have actually a small computer that you can run from your computer, and in this small computer you can run any software, and you can set up this small computer to be fixed at to have a given version of any libraries you need, to have a specific operating system version. So it's really a very good tool for reproducibility, because you can actually be very precise about the versions of what you use. And how you configure Docker is you use what is called a Docker file, which actually defines the installation steps you would have to go through to install and to set up your container. To create your image. I will talk about it later. And similarly to Git and GitHub, you have Docker and DockerHub. So DockerHub is a public host for Docker images. An image is actually what you build when you install your container, and then what you build when you run the Docker file. And then from this image, you can actually launch a container. So it's kind of the blueprint of your small computer, the image. And so DockerHub, it provides actually a public place where you can save images and provide them to the public. You can actually link that with GitHub so that they are automated builds of your Docker files from GitHub done on DockerHub on specific events. Okay, so how do we use all that? So I've taken the bullet points from this slide, A, B, C, D, E, and I will show you how we use different tools for building BIAflows. So when you have a workflow with BIAflows, you will actually put it on GitHub as a repository. You will have to define a set of files. So for reproducibility, you need to provide the workflow and all the scripts, macro, plugins. So to do that, you just put them in the GitHub repository. And so here you have, for instance, the macro, and here you have the workflow itself provided on BIAflows. So you can track actually what this workflow is. You can also have versions that on GitHub that we use to track how a workflow can evolve. For the environment, which is a very important part, as I said, we use Docker. So you have a Docker file in the arrow is not correct. We have a Docker file here that actually contains the installation steps of the environment. What is important is to have very precise versions when you define this. So for instance, here it's for an ImageNet workflow, an ImageJS workflow, and we use a very precise version of EG. And then this Docker file has been used to build an image that is provided on DockerHub that you can pull and work with. Then you have documentation. So obviously, when you create a workflow and it comes with a publication, you will describe it in the publication. But there are things you have to describe in our system to make the workflow work. So we have, for instance, here a descriptor file that contains information about your workflow. What are the inputs? Some description, a name, and etc. And from BIAflows, you can actually access the source code and the environment. So it's a way of documenting your workflow, and also BIAflow itself is documented if you want to use it. It's important to have also documentation for the tool that provides reproducibility. And finally, for data and parameters. So for data, we have a way of storing data sets, problems, or we call them. We have several created problems currently on the main BIAflow instance, and for those problems, we have images and their ground truth. And for the workflow, you can launch them from the platform, and when you launch them, you have the parameters that are explicitly specified for each one of the workflow, and you can actually choose to change them if you want to. We've tried to address all those possible issues of reproducibility with BIAflows, and that's how we've done it. So maybe a quick word about the architecture. So as I said, we have a GitHub repository where the workflow is. Then you have a connection to DockerHub. So when you actually create a new version of your workflow on GitHub, there is some trigger that will trigger DockerHub to build the image of the Docker image of your workflow. And then BIAflow, when the build is over, will get everything, and the workflow becomes available in BIAflows for your problems or any other problems. And then you can do benchmarking on the platform. I'm going very quick about this because you will see more in details how it works during the hands-on session, and you will interact with all those parts. So about the workflow, we are inclusive. So the only requirement for your workflow when you have to package it to fit in the BIAflows setup is so the output should be a folder of omitive images. The output should be a predefined format. So we have what we call a problem class in BIAflows, for instance, segmentation detection, object detection, filament tracing. And so all those problem classes have a predefined output format. Usually it's masks, binary masks. And then you should be able to call this workflow from the command line. That's basically the only constraint you have for your workflow, because actually you can run it in a Docker file. So we don't impose any constraint on libraries versions, because you can define that yourself in the Docker file. And then to define the workflow itself, there are 4 main components that you have to define. You have obviously the workflow itself, which can be a macro, a Python script, an executable, anything that you would have to implement your workflow. You need this descriptor to define what are the input parameters, give a quick description of the workflow itself. And then you need to specify the environment, as I said, with the Docker file. And then there is a Python file that we call a wrapper that actually will sequence the various steps of the execution. So it will connect to BIAflow, download the images, then you run your workflow, analyze the result to upload the result and the matrix to BIAflows. But really, because we use Docker, there's no restriction on the version or on the platform you want to use, as long as you can create a Docker image that contains all the dependencies, you're good to go with BIAflows. And I think it's okay. Do you have any questions?
I would have a short question.
Yeah.
So potentially you answer that later on, then we can skip it. It's just like for the parameter definition, because you said like the parameters are defined or are shown there in BIAflow. So do the parameters need to be defined, fixed, or is it like in a macro possible to have something like a dialog, for example, where the users can test different settings? Or is both possible?
So when you define the workflow, the list of parameters should be defined and fixed. But what happens is when you package your workflow and it becomes available in BIAflows, actually, when you run the workflow from BIAflows, you can select the values you want to assign to those parameters. You cannot add new parameters when it's packaged, but you actually can choose the values of those parameters.
We will demo this in a few minutes.
Yeah. So you do this at runtime to set the values of the parameters, but you also have default values that are hard-coded also in the descriptor when you package it. So yeah, as Romain said.
So I would have a question regarding what you said, that BIAflows is also an image repository. Could you explain a bit more?
Mm-hmm. Yeah, so there will be actually a demo on that after this next part of the presentation. But what we have is actually what we call a problem in BIAflows is actually a set of images that you can upload. It must be, in this case, omitive, because that's what we want to work with our workflows. But yeah, you can store them on BIAflows. You can explore them. I think Raphaël will talk more about it in the demo.
Yeah, so shortly you are able to create some let's say directories or problems where you can put your images there, and you can provide access to other users to these images, and there is a RESTful API which allows you to get the data in and out.
Quick question about the format. Is it limited to omitif, or is there any ideas about supporting next generation file formats like N5 or ZAR?
Okay, so we are currently supporting omitif and TIFF and actually other format in the background, but Yes, we are also investigating the next generation file format. In other project, we also have looked at HDF file, but we are currently looking at ZAR, etc. Yes.
Okay, thanks.
And we actually already support pyramidal TIFFs, no? At least for 2D images.
Yeah, yes, so you can indeed visualize large 2D images because we are supporting pyramidal TIFF formats. And yeah, I can show it quickly later.
Okay, so unless there is another question.
I think there is one.
Oh,
question, maybe you answered the first part, but how you manage the fact that there is now this deep learning workflow. So is the workflow the training part, or is it the prediction, or do you have a workflow for the training and a workflow for the prediction?
So we can support both, but what is currently available in our curated instance is only the prediction part. But basically, it would be possible to have to create a workflow for the training part. So indeed, it would be two workflows, okay. One for the training and one for the test.
Yeah, that makes sense.
Okay, so let's move on then to the next section on benchmarking with Benjamin.
Hello. Yeah, can you hear me? Yes.
Yeah.
Okay, sorry. So the goal of BIAflows is to perform a benchmark on the workflow.
We don't see your slides, Benjamin.
Oh, really?
Yeah. Maybe you could share the whole screen.
Yeah, it's what I did actually. Let me try again. Does it work now?
Yes.
Okay, sorry, I probably did something wrong. So what is a good recipe for a good benchmarking? Well, you need some representative images, either real or synthetic. For BIAflow right now, we work on the OME TIFF format for the benchmarking because it's a standard and it guarantees the fact that we are going to read correctly the different dimensions of the image. Then you need ground truth annotations, either manual or automatic for synthetic images. And then you need one or multiple metrics that will capture the accuracy of the result. So in BIAflows, currently we divided the different benchmark into 9 problem classes: object counting or object detections, landmark detections, object segmentation, pixel classifications, filament tree tracing, filament network tracing, so it's slightly different because it allows loops, particle tracking, and object tracking. So for each problem class, we defined a ground truth type. So I'm going to talk about that in a moment. For the benchmarking, usually you have 2 types. You have real images from where the annotation has been done by a human, or you have synthetic images, and then often the annotation are computed. Of course, the golden standard is are the real images with the human annotations. So currently, the images we have are coming from challenges that made their images public. They are generated for some of them, and they are also coming from data repository or publications. So the ground truth annotation format depends on the problem class, but we have mostly only 4 different kind of annotation format. We have binary mask or label mask. which are in OMITIF 16 bits. We use SWC format for the neuron segmentations, so for the filament problem. And we also use division text file, so which has been described in the cell tracking challenge, to contain the to annotate the program class that are division, so for the tracking of divisions. Because the annotation is very important, we have we sought to establish a list of ground truth annotation tools among us that we would like to share to other people. So I put the link here. I will add it on the chat later on. So it's a Google Sheet where we try to reference the different tools that could be useful to annotate images, depending of what you want to annotate. Benchmark metrics. So I will give an example on the object segmentation because this is the program class we are going to demo today. All the metrics, the detail of the metrics are the information are available through the web interface. If you click on the small information symbol, we have also a documentation page on our on the documentation website. The link is below. I will put it on the chat later on. So for example, for object segmentation, we use a couple of metrics, but we use a dice coefficient, which is basically you take the ground truth object, you take the predicted one, you measure the overlap, and then you compute the dice coefficient according to the formula displayed. So 2 times the intersection on A and B over the area of A plus B. Give you a result between 0 and 1, where 1 is means you have the greatest similarity between predicted and truth. We use actually another metric called mean over the individual average precision, which is a little bit more, you have more steps to compute this benchmark. This metric is used quite a lot now for object segmentation. For example, it's used in the Data Science Bowl 2018 in Kaggle. You don't see the link, but I can put it also in the chat. So you basically have to compute the intersection of our union of the object detected and the ground truth. Then you specify different threshold. So we use the Data Science Bowl 2018 implementation. So we go from the threshold 0.5 to 0.95, incrementing by 0.05. And for each threshold, we compute the precision value given. So basically, the threshold is based on the intersection of union. And so if you are over this value, 0.5, then you consider as true, otherwise you're false. And so from that, we compute the precision value per threshold. And then we do the average precision at intersection of union threshold for a single image. And then we do the mean over the individual average precision of each images, which return a score. And so why do we use multiple metrics? Because often those metrics are complementary, because each metrics capture a different aspect of the performance. So for example, in this example, dice, although it's very good to know if you identify basically the positive pixel of the object, doesn't reflect correctly if the objects are well separated, so well segmented. So it's not a good indicator for segmentation accuracy, but it's a good indicator for detection of the object. Okay. Do you have any questions?
Okay, so if this
Or
part,
maybe you're very impatient, you want to see how it works now.
yeah, we will come back to this metrics anyway during the practical when comparing your own workflows. So then maybe Raphaël, you want to do the demo?
Yes, of course. So let's start by sharing my screen. Okay. Can you see it?
Yes.
Yes.
Yeah. Okay. So I know I will now do the demo of BIAflows. So I will first use the main BIAflows server. So it's biaflows.nebias.org. It's a read-only server because we want it to be clean and curated. So it's not possible to contribute directly to this one. I mean, you are able to browse the content, etc. But it's not possible by yourself to run workflow or add content. But I will also show the BIAflows sandbox server, which this is the one you will use during the hands-on session, where you can do anything, upload data, upload workflows, execute workflows, etc. So here you see the main, the welcome page of the BIAflows server with this flow that is summarized here. So I will show you the way we organize the data into BIA problems. Then I will show you how to explore these BIA problems and look at the available images. Then I will illustrate how to select workflow and execute it. This workflow, as already mentioned, can come from any platform. So we have workflows for images, cell profiler, we have deep learning workflows, Elastic, etc., etc. And for each of these workflows, it's possible to change the values of their parameters. And once you execute them, afterwards, you can see directly the result in a nice web interface. You can visualize these results, for example, here the nuclei segmentations. But in addition to this, you can, of course, also visualize the metrics and compare the metrics for all these workflows on your images. So let's start here. You have the main menu with the problem tab here. So you click on it. And what you see here is the list of the available problems. So we have about more than 10 of these. So they are organized in terms of problem class and in terms of types of images. So you have here a search bar that allows you to pre-select one of these. And so I will look at this one, nuclei segmentation. It's also the one on which you can work during the hands-on. And so when I click on this, it's open the problem tab of nuclei segmentation. Here you have the whole list of images available in this problem. And here on the left, you have different panels, like how to visualize the images. It's this one, how to visualize the annotation, how to run the workflow, and also how to configure this problem, like giving access to other users, enabling some workflows and other configurations. So here you have the list of images. It's a synthetic data set of nuclei. For each of these images, you can get some additional information like the resolution of this image, etc., coming from the omitif file. You have also the possibility to download these files locally on your computer if you are interested in. So now I will open one of these images of this problem. And here, so you have the visualization of this image. So this is the original image. You can zoom in and zoom out. So here it's a small image, but as we explained before, it's possible to look at very large 2D images. It's also possible to look at multidimensional images. I will show this afterwards. So this is one image of the problem, but you can visualize multiple images. So now I have another image. And so you can have multiple views of different images. So you saw these blue contours here, they correspond to the ground truth. So it's possible here in the annotation layer tool to display or not some layers, and here this is the layer corresponding to the ground truth. So for this data set, we have a ground truth, which corresponds to the contours of these nuclei, and so it's possible to visualize this. You can change the opacity of these. And you can, of course, do this for the different images. So here you have the ground truth of another image. So, of course, don't hesitate if you have questions, you just ask them. So this is for the visualization part. What is also possible, for example, I will show you another way to see the ground truth. It's this image. It's the label mask that is actually used by the workflows to compute the metrics. And it's possible to link the two views so that when you move in one of these images, it's also move the other panel. So you can more easily compare multiple images. So this is about the images, but you are very much interested into the workflow. So now I will open this workflow runs tab here. And what you see here is a list of workflows that have already been executed on images of this problem. And so, for example, you have here a stardist workflow, a cell pose workflow, a cell profiler workflow. And for each of these workflows, you have access to the source code. You have access also to the object that it has detected. So, for example, here, this one, if I click here, I can have access to the whole list of annotations that were detected by this workflow. And if I click here, it opens the corresponding image. And so this is the image. This is the detection of this specific run of this workflow. So if I go back here, what you also have here is the exact parameter values that were used when this workflow was run on these images. So you have the detection, you have the parameter values. So let's go back to the detection here. Yeah. And so again, you can have these different views so that you can also compare the detection, or maybe it's not the same image. No, it's not the same image, sorry. Oh, I made a mistake, it's this one. Okay. Okay. So on the left here, you have the detection of the stardist workflow, and here you have the detection, the ground truth. But it's also possible, of course, to have more views. And here I want to see, for example, the detection done by this Python workflow. And in this one, I will display, let's say, the cell profiler one. Okay. And I will link everything now. I will hide this. And so what you have here is the ground truth and the detection of the different workflows that were run on this data. So you can spot differences. Here I don't see strong differences, maybe here. Yeah, you see here these two workflows, these three workflows does not work exactly the same. So that's an easy way to compare the detection of the workflows. But as we mentioned, of course, it's not only about visual observation, but also about metrics. So when you click here on these workflows, you can then display the metrics that were computed on all the images of this project. So it compares the performances of this workflow with respect to the ground truth and with respect to the different metrics, for which you have some documentation here. And you can also display additional, so that was the average, but you can display more metrics if you want, or more statistics. Yes. And what you can also do is not only to look for the aggregated result, but also the details for each image. So for each image of the project, you can get the metrics of the different workflow. And so identify for which image the workflow are not working well. So these were about existing workflow, but it's possible when you have an account that allows you to execute workflows, to execute a workflow by yourself. So I take this one. And so these parameters are the ones that are described in a descriptor that we will better describe later in the hands-on. But basically, this user interface is automatically generated based on a descriptor in JSON, and it allows the users to specify any value. And now I have launched the workflow. It's running in the background, so you don't have to wait in front of your screen. It's running in the background on a computing server using Slurm job scheduler. And so you see here that it's currently running. It's adding annotations now. So the workflow go through all the images of the project, detect annotations using, in this case, it's an ImageJ macro. So maybe while it's running, I can show you that for each of these workflow and each of the versions, you have access to the code here. So you click here and it opens the corresponding version of this workflow on GitHub. So you have access to the exact macro that was used for this workflow. You also have access to this famous Docker files that specify all the libraries that are needed, the exact Fiji version, the exact plugin version, etc., etc. And this descriptor file, which I told you about, which contains description, for example, of this parameter here, that says, okay, this parameter is radius. Here is a short description. Here is the default value. And that's how the BIAflows will automatically generate the user interface. So let's go back to the run. It's finished now. And so I can also add it to the metrics. It's this one. I just execute it now. So you get the metrics for this workflow, for the specific parameters values that I used. So now I can maybe quickly show that it's not only for 2D. So we can support, for example, 3D images. So here what you have is the viewer with the different 3D slides. And you can also display these using colors for the different objects. We have also tracking, for example. So here we have both time points and Z stacks. And we have other problems like the data science ball dataset, etc., etc. So now I can quickly show you how to upload data on BIAflows. So here I'm on the BIAflows sandbox server. That's the one that you will be able to use during the hands-on. I go to the, no, let's start first by creating a new problem. So let's say you want to call it I2K tutorial Wednesday. once you created it, you have access to the configuration. So here you have to specify the problem class. As Benjamin explained you, we have 9 problem class. And so in this case, I will select object segmentation. I will enable the execution of workflows. So let's say this one that I just created a few hours ago. Now I want to upload data, so I will upload images into it. So I take some images. Let's say these 2 ones. Start upload. Okay, they are deployed. I will also upload the corresponding label mask images so that we will be able to compute metrics. They are deployed now. So if I go back to my problem, I see the images here. The ground truth images are also here. So you can see the image. Here you don't see the workflow execution tab. It's because I forgot to customize the UI. So now you see it. And now I am able to run a workflow. And so in the hands-on session, we will allow you to create a workflow based on an existing one and execute it on the sandbox server. And so now it's running. Now it's done. And now I can see the metrics of this workflow I just executed on the images. And again, access to these detections. So I think I showed you most of the features. Maybe Sébastien or others, you can tell me if I forgot something and if you have any questions.
The only thing I would mention is if you could briefly show the documentation.
Oh, yes.
Accessible from the web page.
So if you go to biaflows-doc.neubias.org, it's also indeed available in the front page. So if you go back here, you have documentation here. And so you have the documentation from different points of view. So for example, the user documentation is basically what I showed you, the different problems, how to open an image, activate the layers, visualize the workflow, run the workflows, etc. But you also have documentation for, you have also a video tutorial. You have documentation about how to install BIAflows locally, because we have 2 servers, but it's also possible that you install a server in your own institute. We have documentation about how to add workflows, how to add content. We also have more documentation about the problem class and the formats and the metrics that we require to be compatible. You have some example of samples of images and ground truth, etc., etc. So we spend quite a lot of time to document it, but of course it's not perfect. So feel free to give us some feedback also about the documentation. So is there any question?
Maybe you can also show that we have a forum on Image SC.
Yes. So if you go to Image SC, we have a BIAflows forum there, when you can feel free to ask questions or give us any type of feedback. And we also have this call for contribution, because we are aiming at having more data sets and more workflow into BIAflows. So if you know datasets or workflows that could be distributed, so feel free to contact us.
Okay, maybe I miss a point here. The Docker, for the Docker. So at the end, when you create a workflow, are you able to export automatically or to create an image?
So we will detail this in the hands-on, but basically, let me show you. So there is a mechanism in BIAflows, and that allows to, it's what we call trusted sources. So in BIAflows, you have to configure. We will do it in the hands-on. You can add some trusted sources, so you can specify a GitHub and a DockerHub account, and you can configure GitHub and DockerHub so that they communicate, so that each time you create a release on GitHub of your workflow, so we have release here. Each time there is a new release, because for example you had a bug and you corrected it, or you want to add a new feature to your workflow, each time you have a new release, it will automatically build an image on DockerHub. And BIAflows, because it's aware of this trusted source, it will regularly look into the DockerHub you have configured and pull the images from DockerHub, so that automatically you will have the new version, a new release of your workflows integrated into BIAflows. And to make it work, we will explain you how to do that in the hands-on from A to Z. So I'm sure it will be more clear for you. But basically, it also relies on these Docker files when you have to specify all the libraries that you need. But once you do this configuration of trusted source, etc., once, you will be able to automatically inject new workflows into the system.
And just a naive question about, do we have to use DockerHub, or can we use local Docker servers, or can we use Git, and also can we use GitLab instead of GitHub?
So for the moment, we are only using the DockerHub, but that's obviously one thing that we want to work on very soon. It's to allow to have local Docker servers, because you will notice it during the hands-on. It can take some time once you want to build a new image on DockerHub. It can take some time, so it's delay the deployment of your workflows. But that's something we want to work on, to allow users to configure their own Docker server so that they can build the images on their own server without relying on the latency of DockerHub.
Thank you.